Okay, so today's problem is LRU cache. It's quite standard one. I have limited capacity right now, so I'll probably start coding without explaining my approach, like without drawing my approach. Let me quickly read this problem. Okay, so let me start coding that one. We have a capacity, we will save that into a variable. Capacity equals also we need to have so for the every put, what I'm gonna do, let's assume only use linked list as a solution here. So in order to put value in a cache, I will just put the key value, so I have probably a node, and the node gonna whatever that's so for put, I will just be adding the node into the end of into the beginning of like whatever it is. Like let's say we have a queue-based approach. So you have private queue, and then you have, let's say you have private we have private class, private static class, let's say node, and then we're gonna have public int key, and then we're gonna have public int value, and then we're gonna have public node, we're gonna accept key value. Have this key equals key, this value equals value, and it's going to probably also have this public node default constructor. So in the queue, I'm going to put node inside, and I'm going to call it say queue. Then it's equal new queue node. Can you do that based on the linked list? Linked list, let's say we have linked list like this. And then capacity. So I can get the queue size. So I always can, when I put the value to the and because I only have like in the node, I'm just trying to understand if I can go with just linked list, or do we need to add previous and next value. So let's say we have like a private hash map, and then it's gonna have int key, int teacher, and then do the following. When I'm gonna get, I'm gonna I wonder if like usage of the cache updates so for the get I need to first let's say node cross map get key and then if node goes null I'm gonna return -1 else we need to put it in the let's say in the head because we are getting it again, so we need to okay, so probably I'll do this public node next public node previous and gonna have just node head and then private node tail and then when we are gonna initialize it we're gonna put first head equals new node and then tail equals new node and then I'm gonna have head next equals head pref head pref equals tail next equals head. So this is gonna be just a kind of sentinel nodes. We're gonna keep them always, and when we're gonna get the node, we're gonna check if it's there. Then I need to do the following. I need to set node next equal node dot next and then node previous equals node previous and then I need to do the node next previous equal node previous and node next equals node next. So we remove basically the node and then we need to add it to the head. So we need to do this head prev dot next equal node say head it's called node head previous equal head previous. So head previous next equal node dot previous equals head previous and node dot next equal head dot previous equals node. So this manipulation we put moved it to the head, and then for the put operation we need to do the following. We need to check if the size is equal the capacity. Let's have this private int size and size equals 0, and then every time we put the element, let's say if size less than capacity, it says that more or equal capacity. Let's say if map the get key not equal now, we just need to, again, we need to move to the head, yeah, node element to the head. Let's create a private void move to head, and then we're gonna have node, and then we're gonna copy this one, and then we can paste it here, and then move to head, and move to head node. And then we check if we wanna put, if it's not, we're gonna just move to head. Let's say we have node key. So if the node is not equal now, we're gonna move to the head node, and we're gonna update the value node. Value equals value, and then return. So if you're gonna go with here, we're gonna need to object the list used element. So the list used element gonna be this tail next. Sometimes it's gonna be just head and tail with 0 elements. Capacity can be like maximum, like minimum 1. So this next tail next, let's say node to remove equals this one. So we do the following: to remove ref that next equals to remove that next to remove that next that ref equals this tail. This is basically this tail, and that next equals to remove next, and then to remove this tail next. Okay. Okay, next, that previous, this tail. And then, okay, so we just took it out. And then we need to probably just and then we need to put new element. So we're gonna have node have to head? No, because we currently have no node next. So we can just get it. So node.next equals head node.previous. Okay, node head equals head and then node previous equals head previous and head previous.next equals node and head previous equals node. And when we're gonna put it like this, we're gonna first there are two cases when we need to actually to remove it, so it means that we are out of capacity. If capacity is equal size, if basically size equals capacity, we need to evict the least recently used, so this one. And we need to basically to nullify it in the map. Okay, map remove, and then we have to remove. Okay, and then we need to have size, here size minus, and then here we need to go size plus loss. Let's just do this. So it was 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we need to get 1, 2, 3, 5, 6 at 2. Get at 2. So LRU cache capacity 2, we're gonna put 1, we're gonna then put 2, and then we're gonna get 1. We need to put 3. Get 2, it should return -1. System out and run and out vehicle element. So it should have evicted 2. Why not evicted 2? Let's say for string name the map set in the system. So it was before eviction. Key 1. Okay, 1 value node. After eviction. Let's see. Yeah, it's not removing it. Okay, key. Just remove. No. No. 2. To remove that key. Okay, it's removed. Okay, alright. What about if I change? Let me check what the minute is. So it is 30th minute. Okay, 30 minutes pass. I'm considering probably borderline performance, because yeah, we failed one thing, pretty important issue about like removing actually the value, the key that has to like this put like here. I was removing by to remove basically it's not the key. So I need to go to remove that key to get the actual key to remove from the map. Yeah, so I'll consider it borderline performance, and because like if there is a question should we hire the person or not, and if the performance is borderline, it means that they're not gonna hire a person who makes mistakes in the coding interview. So that's it. I spent some extra time like running the code instead of like paper testing, because yeah, I have limited capacity right now, but I guess it's good because not always you have a tablet and the ability to draw on the interview. Before that it was easier because it was whiteboard interview and you can like draw your debug process on the whiteboard, but now it's hard because all interviews are basically done in Notepad. Some interviews are done through the internal tools, and not all of them allow you to draw something. Other half of the like high-end companies, they have like CoderPad, and there you can draw or like paper test your code, but for the majority of reason you're gonna like paper test it like this with these commands or whatever. Yeah, probably I should have run a few tests there, but I was out of time actually. It takes me like it took me like around 30 minutes to code it like without errors. So yeah, I consider it a fail. Now let me check if I can improve it even further. So they said what's the range for the key, so 10 to the power of 4. So instead of saving it in a hash map, we can actually save it in a private array list, in an array, and you have node, and then you have map equal new node, and then you have 10 to the power of 4 on 1. And then we're gonna need this one, and then we're gonna put the get this one key, put then map that to key equals null, and then here map at index key equals node. So let's try to run this one. Map key, map key. Okay. Yep, even better here. What people do here? Anything implementing linked list, sentinels here and there, like this one. Add to head, delete node, yep, then get, then deleting it and adding to the head. That's nice. Nice API, I like this approach. It's kind of splitting into a couple that might be beneficial on the actual interview. And then he she also array of nodes. Okay. People doing in this cohort. So they're using hash map. Okay. Hash map and what also linked list like own implementation. Okay, what we are doing here? Node, own implementation node and map. Then why it's so a lot of memory? We have key value, path next. We have map. Then probably does it call it printed? No. I wonder, like, when nobody is using linked list standard Java implementation, I would be happy to see something like that, like linked list standard Java implementation, list node. Again, own implementation for the link. Yeah, probably that's how it works in dictionary. map, and the map is what? Hash map. I don't know why the memory is that big there. This is just a bar. Good. Yeah. Okay, I'm gonna wrap up. This is fail.